Hey, everyone. Welcome. Thank you so much for joining us. Today, we are back with another great webinar on laser plastic welding. My name is Jason Dornbos, and I'm the Marketing Communications Manager at Extol. And no, I am not at the Quamanon Falls, but I did take this picture a few weeks ago. We've got an interesting topic today. We'll be debunking laser plastic welding myths. I'm sure we all have various preconceptions about laser welding. Some of them may be true, others may be false, but today we're going to talk about those. Presenting today is Nick Flesher, our Director of Engineering, and also on the line is Ben Lochitz, our technical laser welding expert and applications engineer. Before we jump in, let's make sure that everybody knows how to ask questions. There's a Q&A panel that should be open on the right-hand side of your screen. If it isn't there, you should be able to see a button near the top right that looks like a little chat with a question mark in it. You can click on that and you can open that up. Now you should see where you can enter your name and type a question or comment near the bottom. To test it out, let's have everyone send in one thing that you believe to be true about laser plastic welding. Go, send them in. Throughout the presentation, feel free to send in your questions as they come up, and we'll tackle all of those at the end. With that, let's get started. Nick, take it away.
Thanks for the intro, Jason, and thanks for everyone joining and spending your time with us. And I also want to mention Drew Jelgerheis, our laser sales expert, is not joining us, but you'll see his contact information. So in addition to the questions that you'll ask here, if you have any questions afterwards specific to an application, Drew is also an excellent resource. So with that, we'll go ahead and get going. Overview-wise, we're going to keep this, try to keep this to 20 minutes or so to save time for questions, as well as be sensitive to your time. And right away, we're going to talk about the three key elements of laser plastic welding. Just 2 or 3 slides to talk about the basics of laser plastic welding. We have other content that we'll show a link at the end of the webinar that you can find specifics on different type of laser welding, which we'll touch on in a bit of detail here, but there's more content there. And then we'll talk about the truths of laser plastic welding regarding welding optimization, safety, various part design, configurations, materials, things like that. And then we'll touch briefly on plastic welding machine costs. So before we get into some of those myths, we are going to talk about the laser welding process. A quick overview is 2 parts are clamped together, and that is done by tooling. Typically, you'll see an example of all these in a moment. There is a laser beam that is transmitted through the upper transmissive layer to an absorptive layer, and then there's a hold cycle where that weld is allowed to cure. So we're going to show a video that should come through. We've tested it out, but you never know with video. That shows this actually in process in one of our laser machines in our process development center. And that also shows and explains a little bit about how we approach laser plastic welding here at Extol.
Extol Laser Plastic Welding. Get high quality welds and fast cycle times, all while still meeting your budget. Let's look at the laser welding process from design to finished parts. We start by analyzing your part design and offering recommendations to optimize the weld geometry. We also help you select the best materials for your application, which is crucial in laser plastic welding. Once the design is set and components are ready, we use the part data to create a path around the weld joint for the laser to follow. It is important that the 2 parts being laser welded have intimate contact with each other. To accomplish this, we design tooling that will consistently locate and support both parts. With the tooling in place, it's time to set up the laser welding process. We use the weld path we created earlier and carefully align it to the actual weld joint using a pilot light. We also need to set the laser speed, power, and weld depth. Another critical parameter is force. We need enough force to ensure intimate contact between the components. Once we've optimized the process parameters, it is time to start welding. Fresh parts are loaded and the cycle is started. The press clamps the parts together and the laser beam rapidly traces the weld path at the programmed speed and power. After a brief holding period, the press retracts and we unload the welded part. Laser plastic welding produces clean, precise parts in fast cycle times. When you're ready to start laser welding, talk to Xtol. We'll help you optimize your part design, develop your welding process, and customize equipment to meet your exact needs.
So hopefully that came through for everyone okay, and just gives a sort of compact description of that. And so just to recap, because it is so crucial and actually is a precursor to some of the myths that are out there regarding laser plastic welding, the three key elements, as we call them in Xtol, are intimate contact, IR transmissivity, and absorptivity, and compatible weld materials for the welding. And so to ensure that proper heat conduction, that's what that intimate contact is all about. And that's done via the right sized press, tooling, and weld geometries. IR transmissivity and absorptivity we'll talk about a little bit more in the myth section here. But that's crucial as well to make sure that you have that proper heat conduction up to that transmissive layer. And then compatible materials is the same as any welding technology. We do a lot of different welding here at Xtol, and you have to make sure that you have the proper chemistry between those two parts, so you have similar melt temperatures, and that those materials can in fact weld to one another. So let's get into optimization, or in other words, how difficult is laser plastic welding? We hear oftentimes people may shy away from it because laser plastic welding is difficult. That's a common myth we see. And the fact is that laser plastic welding can be optimized for robustness, speed, and effectiveness. Most often we see that when there's something maybe happening to with respect to absorptive parts or transmissive materials, it's either that the proper absorption content isn't there, 0.2 to 1.5%, usually carbon black from an absorptive standpoint is what is ideal. And sometimes we see higher, sometimes we see lower if it's a film per se. But then also the transmissive materials should consider proper design thickness as well as fill and color content. And we have actually seen, before I move on to the next one, we've seen customers that aren't necessarily controlling this very well really struggle with respect especially to absorptive content. So making sure there's good control of that definitely helps to make that an easier process. So similar to all welding technologies, whether it's hot plate or ultrasonic or vibration, stable molding process is key. And everyone should strive for as much dimensional stability as possible. Now, we see a lot of plastic parts, and we know that can be a challenge. And there are some tricks that we've done with respect to upper tooling and lower tooling and laser plastic welding, but that's crucial. And if you've got some variation there, that might need to be addressed to debunk this myth. Glass and talc filler, but not so much that it exists, but consistency. We've done glass-filled nylons up to 35%, PBTs and the like, really challenging materials up to 2 millimeters or so. And it's not the presence of glass or talc or any kind of filler, but rather the consistency, so that process can be uniform all the way around the weld room. And then lastly, and this one can be tricky sometimes from a design standpoint, but avoiding ejector pins or parting lines on the weld surfaces is really key to make sure you've got good contact. And then to continue that, 2 more points on laser plastic welding being difficult. Have good part design. We can help with this. At Xtol, we've got a process development center that can help with your weld joint design, and just 3 sort of high level items within this category. Making sure that there is an appropriate weld collapse. 0.2 to 0.5 millimeters we see most common, but a lot of times people think, well, I'm not melting as much, so I don't need that weld collapse. And in some cases that's true, but in other, we most often see that it is required. And then sort of adjacent to that is make sure you're designing for flash. It is minimal. It is by far the least flash producing weld technology out there. And you'll see some photos of some examples here in a moment. As you saw in the video, the part, how thin that flash is. It's still important to consider. No welding technology is flash free, as we say. But what laser welding does do is it minimizes the flash less than any other welding technology, and reduces and most often eliminates particulate, which ultrasonic vibration can have. And then before I get to this next point, we're not going to go into detail of these three types of laser plastic welding. They're described on our website, and we can, like I said, we'll share that information. But quasi-simultaneous, simultaneous, and contour welding are very, those are three very common and really the predominant laser plastic welding methodologies. And whether you're using any three of those, making sure the laser entry angle does not exceed 20 degrees, sometimes up to 30 degrees from perpendicular to the surface matters. And what that means is you just need to make sure you have a clean entry as perpendicular to that transmissive layer as possible. Otherwise, you can get some refraction off of that if you consider that angle is too steep. And then I would say have great tooling design. Ensure you've got proper force. We said it multiple times here, but that is key. And at Xtol, we can help you with that tooling design. We see this probably as the most common item and issue that really can pop up with respect to difficulty. Utilize perimeter clamping when at all possible. Internal clamping, we've done a handful of times as well. And there's some other different clamping systems out there that folks have. But make sure that you can uniformly apply that force. And then lastly, repeatable location of the parts within the tooling so that that laser beam path is hitting that weld joint every single time is crucial. Before I go on, Jason, any questions rolling in? How are we doing there?
We do have one question here, and it is, what are the controls included in your system to ensure correct power are always delivered? Correct force, correct speed, all within the control limits, and no burning.
Excellent. That sounds like an educated participant today. Thank you for that really good question. This is key. And what I will say is, because that honestly is probably a webinar that a topic that deserves its own webinar. What I will say is we have a closed loop weld depth parameter that is we have different weld modes within our welding system, so a number of passes, but what we typically see is we press the parts together, make sure that intimate contact is consistent before we even start the weld process, and then we start to apply the energy to the weld rib and watch that collapse as it occurs. And what happens is we see a very consistent weld time to hit that depth. And so our control system has controls parameters around both the weld depth, an upper limit and a lower limit, which is typically done start of production DOE by our customers, or we can control the weld time. So that if for some reason it's taking too long to get to that depth, we see that as well. As far as power goes, that and speed, those are two other key parameters in laser plastic welding. We typically zero in on those at the start of the start of production at that sort of prove out period, along with focus. So that's where laser plastic welding can get even more complicated, and we make sure that all that's done in the design process at runoff, and those parameters are pretty much locked in. So we try to simplify. Our philosophy is how simple can we make it for our customer, right? So hopefully that answered that question. Jason, any follow-ups before I move on?
The only other question here is, should the cover and housing have a gap between each other upon melt? Or do you expect the cover to bottom out on the housing when you're welding?
Yeah, good question. Wow, that's super observant. That actually was a very simple demo. We have to be careful to make sure we're not showing customers' parts. So that's just a demo part that we had, which actually had that designed in. We had to do some modifications to that. And so that was designed in, and the collapse on that, I believe, was 0.3, 0.4 millimeters of collapse. Is that right, Ben? Am I speaking quite right on that?
That's correct. And then for the gap, there should be a slight gap at the end of melt. You do not want a hard stop.
Yeah, so great question. Or a great comment, Ben. So we will often see, and if we're recommending, and someone can have a conceal, 0.2, 0.3 millimeters, depending on the part size. It really varies, but yeah, good observation. That was much more gap than what's actually required in the flash that you saw in that image. And I actually got a text from one of our internal folks that says we froze up, so hopefully everyone saw that. You can see it on our website, on our landing page at the end if you want to watch that again. That's representative of a 0.3 to 0.4 millimeter collapse. So let's keep moving. I want to save some time at the end and make sure we try to get everyone out to get on with their day in 20, 30 minutes or so. Let's talk about safety. This obviously is a crucial component. There's a myth out there, and we've run across it. Hey, is laser plastic welding actually safe? And the fact is that when a system is properly designed and that there's the right sort of front-end work happens, laser welding systems are certified safe. So even with various wavelengths, we typically use 980 nanometers. You can have in the 900 nanometer, low-end 900 nanometer, even lower than that, up to 2000 nanometers or 2 micron. Laser welding is done in safe machines, and we ensure it by a risk assessment in the design process if it's a configure solution, if it's a custom configure solution. And then we do an end-of-line light test as part of the safety reporting process that we need to do for the FDA. And then we have a certified laser safety officer on staff to do that evaluation. So that's crucial. If you're thinking, well, I want to see if I can do this with another source, that is a very key item to make sure that you are safe in your laser welding system. Okay, so another myth we come across, hey, laser plastic welding is for flat, small parts, right? Well, not necessarily. In fact, we often see that that's not the case. Larger, more complex parts can be laser plastic welded. One key benefit for sure is that laser welding and its ability and very small beam spot and precision is great for welding small parts. However, large parts and three-dimensional parts can also be welded with laser plastic welding. I mentioned a little bit the 3 types. Again, check that out on our website. But quasi-simultaneous and contour welding, which we do the most of, is feasible with proper tooling and laser hardware such as multiple clamps, 3-dimensional scanners, gantry systems. And then just to be aware, 3-dimensional parts can also be welded with simultaneous laser welding with steeper angles and more contour if needed. So let's talk about clear parts. Well, you talked all about this absorptive layer, right? It's key. We've got to make sure we have that. But the fact is, clear-to-clear welds can be achieved with laser absorbing agents. Adding an absorbing material into the molded material or prior to the welding topically can yield a very robust and quite a fast weld time with a wide process window. These are just 2 examples. The one on the left is an excellent supplier that we've used, Clearweld, and the one on the right's a different company. But what I'll say about this is two more things that aren't on the slide. The absorbing methodology is crucial. It is something we've done some development work on, and we've got a system that we do that sort of work. And we worked with a couple different suppliers and found one to be better that makes absorbing dispensing systems. It is not something you can go haphazardly on, and really needs to be a part of the laser welding process. But once it's dialed in, it can be quite robust in manufacturing. It's been around for a long time. And then the other item to be aware of with clear parts is 2 micron. Essentially what's happening with 2 micron, again, there's white papers out there on this, and that could have its own, but both the top layer and the bottom layer of the clear are energized by the layer, and both are heated. So the process window, the way that that energy comes in, the optics to make sure that that's focused at just the right spot is key to that type of welding technology. And we've worked with a supplier of that wavelength laser to do those sorts of applications. So if you see that and you want us to take a look at that, we're more than willing and capable to do that. You guys jump in here if there's any questions. So opaque parts, laser welding is only for clear to black, right? The fact is, optically opaque materials can be laser plastic welded. These are 2 really good examples that from one of our step plaques that we can mold for you, either with your own material if you're a customer, or we can work with the resin supplier to dial those in. And essentially what's happening here is optically they look opaque, but the infrared wavelength that we're using for our laser is transmissive. So you can kind of see that polyamide 6.6 there, and this is I want to say 1.5 millimeters thick. We can go all the way to 2.5, and polycarbonate, both laser plastic welded, and you can barely see, it's kind of small on my screen, but you can see the flash on the side is very, very narrow on that. So quite robust. We've got a laser inspection system, optical system, and you can see right through it as if it's clear as can be. So, and then one thing that's worth noting, just because we're touching on opaque parts, there is sort of a degree of difficulty, if you like, complexity around welding opaque parts. So you can see left side, very, very straightforward, much more window on materials and process and things like that of the clear to black. And there is a progression of difficulty that is out there from a black to black, color to black, clear to clear, as we talked about, a couple methodologies to that. And then believe it or not, the most challenging is white to white. Getting that laser energy through that top layer to that absorptive layer without affecting it can be a bit challenging. So it's feasible, it's doable, but it's just it's something to be mindful of. And one of the key suppliers that we use, kind of a leader in the industry, RTP, has a great 2-pager out there that you can see there. So check that out. And then lastly, and maybe the one that gets probably the most attention, is laser plastic welding is expensive, right? Well, with our approach, and I'll talk about that in a second, laser plastic welding can be tailored to your needs and in a budget that works for you. Taking an application-specific approach, which is what we do, can provide a cost-effective way to approach laser plastic welding. And we do that by ensuring you've got the right power and not too much, the correct optical systems, the guarding that's required, and bases and tools that are configured to your needs, instead of trying to fit customers into maybe a standard machine or one that's engineered different. So we use start models and some other ways to try to get that down. Integration packages, benchtop systems we quoted in the low 100s, 110, 120 range, 130, up to turnkey automation systems into the $500,000, $750,000 with multiple laser sources and dials and things like that. So, make sure that if we're competing with other, if laser welding is competing with other technologies, you consider a couple things: the weld quality, flash, particulate, in particular, and is it actually fitting your need? We've seen some systems where we're quoting 10-watt systems. We've seen systems where we're quoting 500-watt, 750-watt systems, air-cooled, by the way. And so when you consider cost, consider quality. We've seen customers who vibration weld and who need clean out stations. And so they think welder and they think, oh, well, I've got a system that's lower cost for vibration welding, but yet there's part fallout, there's internal cleanliness specifications they need to meet, clean out stations and the like. So make sure you're considering the whole big picture, and that our solution is more to be configured and tailored around what you actually need. So that concludes the presentation portion. We'll open it up to any questions that hopefully you had along the way here.
So, Nick, does Extol offer fully automated laser welding lines, or is it just like standalone turnkey machines?
Awesome question. Absolutely. Anything from pick and places through conveyors, dial systems, as I mentioned. Our company does improving plastic products as a whole, and so making sure that the solution and our departments mesh interchangeably with our automation group. So it's again in that sort of strategy around how do we configure that system to what's needed and what's required, and particularly in the medical community where you might be looking at the $500,000 type of part range. We'll absolutely look at how fast can we get the weld so that we're meeting the need of the production.
Another question is, can laser welding be implemented on an interchangeable tooling pack?
Yes, absolutely. We've got quick change tooling that can be quoted as part of our systems. So if you've got some, the right kind of manufacturing requirement on what kind of parts, it's a pretty simple, straightforward, quick change tool. And keep in mind, if you're trying to consider that, that's completely feasible, and we've done that and created that. The repeatability, you've got to have proper location in there so that when you do those tool changes, there's no reset required. And we've got experience with that. We've done that.
Well, that's all the questions that we have for now. If anybody on the line has a more specific question or wants to talk about a very specific application, feel free to do that. We'll be sending you a follow-up email later today or early tomorrow with a link to watch this video pre-recorded, or it's not pre-recorded, but the actual recording of this event. We'll also send out a PDF of the slides that'll be available for you. And then, of course, you'll be able to reply to that email with any additional questions that you might have or details about an application for laser welding. Even if you're just curious, you have something that you don't think could be laser welded, but maybe it could, you never know. Send that in, we'll take a look at it and be able to help you determine whether laser welding is the best option or if you should consider some other type of plastic welding. Thank you everybody for joining us today, and have a great afternoon.
Thanks everyone.